Somewhere in the deep sky, our most powerful telescope keeps finding things that, according to our best science, simply should not be there. Galaxies too big, too bright, and too grown up for their age. Structures that had no business existing when the universe was still a newborn. And the deeper the James Webb Space Telescope looks, the worse the problem gets. Every one of these discoveries chips away at the story we thought we understood. The neat account of how everything, from the first stars to the galaxy you are sitting in, slowly came to be. That story is now cracking, and the cracks are showing up right where the universe is oldest and youngest at the same time, out at the very edge of what we can see. This is not a tale of a broken telescope or of scientists getting it wrong. It's stranger than that. It's the story of a machine working perfectly and revealing a cosmos that flatly refuses to behave. So let's follow the trail of impossible objects, one at a time, out toward the beginning of time itself, and watch just how troubling the questions become. Start with a monster, a galaxy cluster called XLSSC 122, one of the biggest kinds of structures that exist, a colossal city of galaxies bound together by gravity. It sits about 10.4 billion light-years away, which means we're not seeing the cluster as it stands now, but as it looked 10.4 billion years ago, when the universe was only about a quarter of its present age. According to the standard model of cosmology, that is far too early for a cluster like this. Gravity is supposed to be patient. It takes billions of years to gather scattered gas and galaxies and pack them into a mature, tightly bound cluster. A structure this evolved, this organized, was simply not supposed to exist yet. And yet there it is, already fully grown, in an era that was meant to be the cosmos's awkward childhood. There's more, and this is the part that unsettles researchers the most. XLSSC 122 is so massive and so dense that its gravity is visibly bending the light of galaxies far behind it, smearing them into long, glowing arcs. That makes it the most distant object ever caught warping space on the scale. By measuring exactly how the light is bent, astronomers can weigh whatever is doing the bending. The answer comes back as dark matter, the invisible scaffolding of the universe. And in this cluster, there's far too much of it, packed far too tightly, far too soon. The dense, dark heart that should have needed many more billions of years to assemble was already sitting there, finished. Webb even caught a faint glow drifting in the gaps between the cluster's galaxies, the light of stars ripped loose during ancient collisions and left to wander the space in between. It's the earliest example of that ghostly glow ever recorded, a sign that XLSSC 122 was already slamming its galaxies together and rebuilding itself at an age when gentler clusters had barely started. To be fair, one overachieving cluster does not prove the whole model is wrong. Science does not work that way. A single exception could be a fluke, a rare early bloomer. But XLSSC 122 is not alone. It is one clue in a fast-growing pile, and the next clue lies much, much farther away. To grasp how we can even see these things, you first have to accept that a telescope is a time machine. Light is fast, racing along at about 186,000 miles per second. But the universe is so enormous that even light takes ages to cross it. So, a galaxy billions of light years away is showing you light that left it billions of years ago. What reaches the telescope is not the object in its present state. It is a snapshot of the object's ancient past. There is a second trick hidden in that light. As the ancient beam travels for eons, the universe itself keeps stretching, and the light stretches along with it, its color sliding toward the red end of the spectrum. The effect behaves like the falling pitch of a siren racing away from you, except with light instead of sound. The farther the light has come, the more it gets stretched, and astronomers call that redshift. Measure the redshift, and you have pinned down both the distance and the age. There is a reason those first few 100 million years are so hard to reach. In the beginning, there were no stars at all, only a thick, dark fog of hydrogen and helium filling every corner of space. Cosmologists call it the cosmic dark ages. Then, the earliest stars finally ignited, and their savage ultraviolet light began burning through that fog, tearing it apart in a process called reionization, until the universe at last turned clear and transparent. That turning point The cosmic dawn is the exact era Webb was designed to hunt. This is exactly why the James Webb Telescope was built the way it was. The huge golden mirror, more than 21 feet across, is tuned to see infrared, the deep red glow that the oldest, most stretched signals arrive as. Webb floats about 1 million miles from Earth, hiding behind a sunshield the size of a tennis court, chilled to hundreds of degrees below zero, so its own warmth cannot blind it. The result is a machine built to catch the faint reddened whispers of the very first galaxies, and recently it caught one that stopped astronomers in their tracks. You are now looking at the most distant object humanity has ever seen. It has been described as a kind of cosmic miracle. Its formal name is MOMZ14, and its light has been traveling toward us for more than 13.5 billion years, crossing the expanding universe, stretching and reddening the whole way, until those exhausted photons finally settled into Webb's mirror. When that light first set out, the universe was around 280 million years old. Put another way, it was barely 2% of its current age. To feel how early that is, shrink all of cosmic history down into a single calendar year. If the Big Bang is midnight on January 1st, this galaxy was already shining by about January the 7th. The dinosaurs would not turn up until the day after Christmas, and the whole of human history fits into the final few seconds before midnight on New Year's Eve. We built a machine that can see almost to the first page of that calendar. And what it shows makes very little sense. MOMZ14 is tiny, only about 240 light-years across. Our own Milky Way is roughly 100,000 light-years wide, which makes this ancient galaxy hundreds of times smaller. Yet, it's blazing, wildly more luminous than anything that small and that early has any right to be. Our models of how the first galaxies flickered to life simply did not predict something this bright this soon. Then astronomers studied its chemistry, and it turned stranger still. The galaxy is unusually rich in nitrogen compared to carbon, a fingerprint we normally find in globular clusters, some of the oldest, most tightly packed swarms of stars in existence. We'd already assumed those took a good while to come together. But if their chemical signature is already stamped into a galaxy less than 300 million years after the beginning, then the universe was assembling sophisticated structures almost the instant it was capable of it. That was not supposed to be possible, and it's not a one-off. Since Webb switched on, this has happened over and over. Galaxy after galaxy has surfaced in the early universe looking too bright, too massive, or too chemically mature for its age. When one team turned up a handful of enormous galaxies that seemed to exist when the cosmos was only a few percent old, headlines dubbed them the universe breakers, because, on paper, they held more stars than there had yet been time to build. Other surveys keep finding strange glowing specks called little red dots, whose true nature astronomers are still fiercely debating. And the top of the leaderboard never stays still. Not long before this newest record, the most distant galaxy known was a different object, glimpsed about 290 million years after the Big Bang. It wore the crown for barely a heartbeat before it was beaten. This is how fast this frontier is racing. The oldest thing in existence keeps getting older, and each new champion arrives more troubling than the one before. So what's actually going on? The honest answer is that nobody's sure yet, and that is less a crisis than an invitation. Our models are not necessarily wrong, but something inside them is clearly missing. Perhaps the first stars were far larger and burned far more fiercely than we assumed, flooding their galaxies with unexpected light. Maybe those early galaxies were freakishly efficient at turning raw gas into stars, far beyond anything we see today. Dark matter may have herded the building material into dense clumps faster than our simulations permit. Or the missing piece could be an ingredient in the recipe we have not yet even imagined. This is what real science looks like when it collides with a surprise. Not a collapse, but a scramble. A rush of competing ideas racing to explain the impossible. The universe handed us a puzzle it was never meant to, and every fresh image from Webb sharpens it further. But a few scientists staring at these anomalies have begun to wonder whether the fix is not a tweak to our models at all, but something far more radical about the nature of reality itself. And this is where the story takes a genuinely strange turn, the kind that sounds like pure science fiction until you see the evidence sitting behind it. Because a separate discovery teased out of those very same Webb images has led a handful of serious physicists toward a conclusion that ought to be absurd. That everything you have ever known, the entire visible universe, might be sitting inside a black hole. It begins with spin. When researchers sorted a large batch of Webb's early galaxies by the direction they rotate, they expected a coin toss, roughly half turning one way and half the other. In a truly random universe, this is what you should find. Instead, they saw a clear, lopsided majority spinning the same way. On the largest scale, the universe seems to carry a preferred direction, a subtle handedness it is not supposed to have at all. And the spin is not the only hint of a hidden grain. When scientists map the very largest structures in the sky, some report a faint alignment in how galaxies are arranged and how they drift, as though the whole cosmos leans ever so slightly one way. If that leaning is real, it would quietly overturn one of the oldest assumptions in the field, the comfortable belief that the universe looks the same in every direction and plays no favorites at all. One explanation on the table is startling. What if our entire universe was born spinning because it formed inside a rotating black hole in some larger cosmos? The idea has a name, black hole cosmology, and it is more serious than it first sounds. Consider what a black hole actually is. Matter collapses under its own gravity to a point of unimaginable density, sealed behind an event horizon, a boundary that nothing, not even light, can ever cross. Now, consider the Big Bang, which our own standard model traces back to a point of unimaginable density. The resemblance is difficult to ignore. On this view, the Big Bang was never an explosion out into empty space. It was what a collapse looks like from the inside. When matter crushes down to form a black hole in a parent universe, some physicists argue it may not vanish into an infinite point after all. A twisting property of space itself, linked to the spin of particles, could arrest the collapse and hurl it back outward, a kind of cosmic bounce that blossoms into an entirely new universe. Ours. If that is right, then every black hole scattered across our own night sky could be the seed of another universe budding quietly inside it. An endless family tree of cosmoses giving birth to more cosmoses. The idea even throws in a strange bonus. A black hole stores a staggering amount of information, which echoes the vast complexity packed into our universe. And this is the detail that raises the hair on your neck. If you take all the visible matter in the observable universe and ask how large a black hole it would make, the size you get is remarkably close to the size of the observable universe itself. That might be a meaningless coincidence, or it might be a clue we do not yet know how to read. It would be dishonest not to state the obvious. This is a bold, unproven idea, and most cosmologists are nowhere near ready to sign on. There is a far less dramatic explanation for that lopsided spin waiting in the wings, that our own galaxy's motion is quietly skewing the measurement, a mistake to be corrected rather than a revolution to be crowned. Extraordinary claims demand extraordinary evidence, and that evidence simply is not in yet. Even so, the black hole universe is far from the only crack in the wall. Cosmology is quietly wrestling with another one, known as the Hubble tension. When scientists measure how fast the universe is expanding by watching nearby stars, they get one number. When they calculate that same expansion from the faint afterglow of the Big Bang, they get a stubbornly different one. The two answers refuse to line up, no matter how carefully the work is checked. Something in our grasp of the expanding universe is off, and nobody yet knows what. Line them all up. The impossible early galaxies, the lopsided spin of the cosmos, the running argument over how fast everything is flying apart, and a pattern comes into focus. Our map of the universe, built up over a century of brilliant work, is bumping hard against the edges of what it can't explain. None of this is a failure. Every one of these troubling questions is a door, and Webb has kicked several of them open at once. The most distant galaxy we know of today will not keep its crown for long, and each fresh discovery drags us a little closer to the very first light that ever shone. Somewhere out there, just past our current reach, sits the answer to how all of this began, and we are already building the machines to go and read it. For now, we are left holding the most humbling realization in modern astronomy. The universe is not the tidy, well-mannered place our textbooks once described. It's older and stranger and more surprising than almost anyone dared to guess. And the more sharply we see it, the less we seem to understand. That's not a reason for despair. It's the best possible reason to keep looking up. And if a cosmos that refuses to obey its own rules fascinates you, consider one more of its impossible contradictions. Space is crowded with billions of blazing stars, and yet it's colder than Antarctica. We unravel exactly why in our video on why space is colder than Antarctica, even with billions of stars. Watch that one next.